This is modes of representation, looking at level 23. We're asking, is 12 equal to y a function? Give a reason why this is or is not a function. Complete the mapping diagram by finding all the targets of each of the given antecedents. These are the antecedents, these are the x values. The targets are the y values. We have an equation y is equal to 12. That means y is always 12, no matter what the x is. If you plot that, you don't have to plot on this level. When x is 0, y is 12. When x is 3, y is 12. When x is 6, y is 12. When x is 9, y is 12. When x is 12, y is 12. We're talking about a horizontal line like that, right? Make our mapping diagram by making these arrows. Everything points to 12. This is called a many-to-one function. It's a function because there is one y value for each and every single x value. Yes, a function, and it is many to one. It passes the vertical line test. If you drew a vertical line like this, it will cross through the line that we just drew exactly once. It is a function. Then press enter to see if you're right. Here's another one. I want to get the y all alone. Add y to both sides. I want to get the y alone on one side. Add y to both sides to get rid of it from this side. I'm also going to add 5 to both sides to get rid of 5 from this side. Add 5 to that side. 2/3 x plus 5 is equal to y. 0, we're going up by 3s, is equal to that plus 3. Fill that down. It's a little bit faster to do it that way than to write each number. The y values are equal to 2 divided by 3 times the x values. These are the x values, and then plus 5. We'll fill that down. These are the y values, and that's what we need. Click on my text box, make 5 text boxes like that. Fill them in. The first one's a 5, the next one's a 7. The order doesn't matter. 9, 11, and 13. Then we have to set up our mappings. We're drawing our arrows. 0 is mapped onto 5. The 3 becomes a 7. When you put in an x value of 6, you get a y value of 9. You can also click on the number and then click right in front of the other number. It makes the mapping notation. Is this a function? Yes, it is. For every one x, we have one y. It's a 1-to-1 function. You can graph this if you want. You don't have to. If you did graph it, you can graph these points, or you can graph it using y equals ax plus b. The b is 5. If I go over here, click on my 5, then the slope is 2/3, moving over 3, 1, 2, 3, up 2. This is my line, or I could plot 0, 5, 3, 7. There's my 3, 7. All the way up to 12, 13. Here's my 12. There's my 13. You can plot it, and notice it does pass the vertical line test, so it is a function. Then I'm going to press enter to see if it's right. Here we have x plus 6 is equal to 0. I want to get the x alone. I'm going to subtract 6 from both sides. That gives me x is equal to -6. No matter what the y value is, the x is always 6. And if you graph that, you end up with a nice line like this. That x is always -6. You have a vertical line, and it fails the vertical line test. If you draw a line through that, it hits at every single point. X is -6. Y could be anything you want. If I wanted to make it 12, 14, 18, 22, when x is 6, it could be really anything. I'm going to put that in. 12, 14, 18, and 22. It doesn't matter what these numbers are. You can put any numbers in. You need to put in at least 3 of them. Is this a function? No, it's not. It fails the vertical line test. It's one to many. Anytime that you have many for the y's, it's not a function. One to many, and then press enter to see if you're right. -2 is equal to 12 times x take away 10 squared take away y. I want to get the y all alone. Add y to both sides. I want to get rid of this -2. Add 2 to both sides. That gives us y is equal to 12 times x take away 10 all squared plus 2. We have 8 is equal to the 8 plus 1. Fill that down, is equal to 12 times, open bracket, the x value, take away 10 to the power of 2 plus 2. That gives us 50. Fill that down. Notice we only have 3 unique values, 50, 14, 2, and then we have 14 again and 50 again. And we're only going to put 3 boxes. If you put 2 boxes with the same number, it will say that you are wrong. 50, 14, and 2. But the order here that you write them in doesn't matter. 8 gets mapped onto 50, 9 gets mapped onto 14, 10 to 2, 11 to 14, 12 to 50. This is a function. If we graph it, it's going to give us a parabola. 8 and 50. Here's my 8. Don't see the 50, so I'm going to scroll this down. Here's my 50, 8 and 50. We also have 12 and 50. We have 9 and 14. 9 and 14. We have 11 and 14. We have 10 and 2. 10 and 2. But we do have a parabola. We could zoom out. It keeps going on like this, but it's only drawing the points that you plotted. It totally passes the vertical line test. If you draw a vertical line, it will only cross through once. No matter where you draw it, it's only going to cross through once. Yes, this is a function. Many to 1. Both the 8 and the 12 go to 50. Yes, for function. And many to 1. And then you press enter to see if you're right. This is an absolute value relationship. We need to solve that as an equation. I want to get the y all alone, add 3 to both sides, and that gives me 7 times the absolute value of y plus 4 is equal to x plus 3. I want to divide both sides by 7 to get rid of that 7, and then we're left with the absolute value of y plus 4 is equal to x plus 3 over 7. Okay, to get rid of the absolute value, we're going to look at the positive and the negative of it. For example, like if you had the absolute value of negative 3, that would give you 3. But if you had the absolute value of positive 3, that would also give you 3. If you have the absolute value of x is equal to 3, that means x could have been positive 3 or it could have been negative 3. You have to take care of both. Y plus 4 must be positive or the negative of x plus 3 over 7. Put that in brackets because it's not plus or minus x, it's plus or minus the whole fraction. I want to get rid of that 4. Subtract 4 from both sides. That gives us y is equal to plus or minus the x plus 3 over 7. Take away 4. We have 3 values, 11, 4, and minus 3. It's equal to, I'm going to start with the negative value. Negative, now I can't write negative brackets. I'm going to write negative 1 times bracket x plus 3, close bracket, divided by 7. That minus 4. It's not the 7 minus 4, it's the whole fraction minus the 4. It's not x plus 3, it's a 4 plus 3. Okay, that gives me minus 6. Fill that down. Then I want to look at the positive versions of that. So I'm just going to fill that right for a second. Change my B4 to an A4. Change the negative to a positive. We have negative 6, negative 5, negative 4, negative 3, negative 2. I can put that in any order. Negative 6, negative 5, negative 4, negative 3, negative 2. The 11 gets mapped onto the negative 6 and the negative 2. 4 gets mapped onto the negative 5 and the negative 3. The negative 3 gets mapped onto the negative 4. That's one to many. Is that a function? No, it's not. If you graph this, you end up getting 11, negative 6, and 11, negative 2. Negative 6 and 11, negative 2. We also have 4, negative 5. There's my 4, negative 5, 4, negative 3. Looks kind of like a parabola until we do our last point, which is negative 3, negative 4. That's not a parabola, that's an absolute value. It looks like a sideways V. It just keeps going on in this direction. I can put in other values. X is equal to 25. Gives me negative 8 and 0. Negative 8 and 0. So there's my 0. There's my negative 8. Like that. So it just keeps opening up like that. And it fails the vertical line test. If you drew a vertical line through it, it would cut through it twice. There's your vertical line, slices through it twice. Was this a function? No. And the reason why is it is one to many. For this one x value, you got two y values, one to many. And then press enter to see if you're right. And that's it for level 23. Have a good day.